Hello and welcome back to Zig's Math Lessons. I am your host, Ziggleby B. Stunk. Thanks for dropping by. Let's get started with learning how to analyze and graph those trig functions. Sinusoidal functions, they're sometimes called. Let's recall the basic transformation equation, y equals a sine of b times x minus d plus c, where a is a vertical stretch and if negative reflects in the x-axis. B horizontally compresses, and if it's a sinusoidal function, it will affect the period. D shifts the whole thing to the right, and C shifts the whole thing up. The amplitude will be A. So the amplitude of the sinusoidal function will be whatever the coefficient is out front. Meanwhile, the period, P, will be 360 divided by the factor on x. So the period will always be 360 divided by this number here, which is in front of the x. And if we seek the number in front of the x, we can get it, because b will be 360 divided by p, because in this configuration, p and b can swap places. So p and b have a relationship mathematically. Since we know that the period p is 360 over b, let's answer a few questions just for practice. Here we have a b value of 2, so the period must be 360 over 2, 180. Here we have a b value of 4, so the period must be 360 divided by 4, and that's 90. And of course it works with fractions too. Here we have a b value of 1/2, so the period must be 360 divided by 1/2. And of course, when we divide by fractions, we invert and multiply. And so the period will be 360 times 2, 720. Check these remaining ones out for yourself, and you'll find that if the b value is 2 over 3, then the period, will be 360 divided by 2/3, and that is 540. And the last one is 1080. Here's a graph. One of the skills is to look at a graph and state the equation. Another skill is to be given an equation and create a graph. Let's start with given this graph, state its equation. Now, the trig functions can be a bit daunting, so one good approach is to always say, okay, I'm going to state the amplitude and the period. It's a good way to get started. So the amplitude. The amplitude we know is the distance from the middle, which is the axis of the curve, to the maximum, which in this case is 1.5. So the amplitude is 1.5. And we'll consider this a sine curve. The amplitude being 1.5. Now if we are to consider this a sine curve, then we have to think normally a sine from the previous lesson starts at the origin and goes up. So normally it starts at the origin and goes up, but in this case it starts from the origin and goes down. So we would have to say that it's been reflected across the x-axis. So we have an amplitude of 1.5 reflected across the x-axis. The period is next, and the period is the measurement. Well, it could be the measurement between the mountain tops, it could be the measurement between the valley bottoms, or it could be the measurement of an entire cycle, starting, say, here at the axis, going up and going down and coming back. So the distance between 90 and 270 is the period of this curve. And that's 180 degrees. Now we're building an equation, so what we really seek is the b value. And we know that b is equal to 360 over p. So it's going to be 360 over 180, and that's 2. Now we know that the b value is 2, and the a value is 1.5, with a negative sign in front of it because it's been reflected across the x-axis. So we can now state the equation of this curve. Using our transformation equation, knowing that the amplitude goes here and the b value goes here, and this one hasn't been shifted up or down or left or right, we can simply say that the equation is negative 1.5 sine 2 theta. Let's do it again. This curve could be a cos curve or a sine curve. Let's consider this one a cos curve, because it starts at a mountaintop at the y-axis and goes down. And that's what the cosine curve does. A cos curve starts with a mountaintop at the y-axis and goes down. We could consider it a sine curve, but let's consider it a cos curve. The amplitude is 0.5, the distance from the axis to the maximum. Now we have to measure the period, because our approach is always amplitude, then period. So the period is from this mountaintop to this mountaintop, but I don't know what number that is. I can't tell. So I could measure 1, 2, 3 periods. I can tell that one's 360. So 3 periods are 360, which means that 1 period must be 120. It's kind of like dividing through by 3. Again, though, we're more interested in the b value than the period, and the b value is 360 divided by p. So it'll be 360 divided by 120, and that's 3. Now we've got a b value, and we've got an amplitude, and so we can now state our equation. 0.5 cosine 3 theta. Another skill you need is to be given an equation and create a graph. We'll use the same approach that we've been using, which is amplitude and period. The amplitude being this number, this coefficient out in front, is the amplitude. And the period being 360 divided by 2. Amplitude and period, a great approach. Amplitude is 1.5, and the period is 360 divided by 2. That's 180. Next, we make a rough sketch of a cosine. Roughly speaking, that's what a cos curve looks like. And on our rough sketch, we're going to number some points. These are going to be the points in the order that we graph them. Point 1 is the y-intercept. Point 2 is a period displaced to the right, an entire period to the right, point 2. Point 3 is in the middle, halfway. It's the halfway point along the curve. And points 4 and 5 will be the x-intercepts. If we can graph those 5 points, then we can join them together and we've graphed the curve. Let's attempt to graph those 5 points. Point 1. Well, let's see. Point 1 is an amplitude above the origin. So we'll go to the origin and we'll go an amplitude, which is 1.5 above the origin. So we'll go to there and we'll put a point. Point 2 is 1 period displaced to the right. It's a period displaced to the right. A period is 180 degrees. So we'll go to this point and we'll go 180 degrees displaced to the right and put a point there. Point 3 is in the middle between 1 and 2, but here's where you got to look carefully. If I went to the middle between 1 and 2, here, I would have to go 1, 2 amplitudes down. an amplitude to get me to the axis, and another amplitude to get me to the minimum. So that's what we'll do. We'll go to the middle here, and we'll go 2 amplitudes down. And an amplitude is 1.5, so we'll have to go 2 times that. We'll have to go 3 down. 1 amplitude, 2 amplitudes, and put a point there. Next, points 4 and 5 are the intercepts, and they are in the middle, this way, at the axis. Points 4 and 5. So we've graphed the 5 points in the proper order. Now we join them together in a sinusoidal curve. Our next task is to fill out the domain with this curve repeating itself. To fill out the domain with repetitions of this curve, it's fairly easy to do if one carefully and evenly places points along the axis of the curve. See these 2 red dots? They're separated by 2 ticks. So all along this axis of the curve, I'm going to separate points by exactly 2 ticks. So I'll put one here, and here, and here, and here. Go back the other way and put points here and here. Now with these points as a guide, and knowing that the maximums and the minimums occur in the middle, we can fill out the entire curve, the entire domain. With these points as a guide, we can fill out the domain. And there it is. Y equals 1.5 cosine 2x. I'll be back with a couple of more examples of how to graph trig functions soon. I'm Ziggleby Stunk, and thanks for watching. If you like the video, leave a like, and if you like the content, please subscribe. Check back daily for updates and new videos, and I'll see you soon.